Hello, hello, hello. Hello, testing 1, 2, 3. Hello, testing 1. We are going to start in 2 minutes. And I'm very happy that all of you are already here. I really enjoy this moment, and I'm really sorry to disturb all of you in the kitchen area, but yes, we'll have breaks, don't worry. Well, it looks like we can start. My name is Ekaterina Firsova. I'm a chair director of Altenar, and I'm very happy to welcome all of you here on our Malta Tech Talks. First of all, who are first time here? Please hang your hands. Oh, really? First time? Are you serious? So big amount of people? Wow! It's amazing, to be honest, and I'm very happy that you will participate. That's why let me tell a little bit about how usually it works. We will have 3 presentations, very short and interesting about different topics, and around 25 minutes each. After that, we will have Q&A session, and I kindly ask you, don't be shy, please ask questions. Sorry. But I'm pretty sure that it's the most interesting part, answering questions. After that, after all 3 presentations, we will have a break. We still have a lot of food, a lot of drinks. And thank you, my lovely company Altenar, for giving this opportunity to meet each other, networking, sharing ideas, and just have fun and food. Well, I'd like to invite our first speaker, Yanis, who is our architect in Altenar. Welcome.
Thank you, Katerina. I can be heard, right? Okay, good. Okay. So, let me welcome you as well. This is a presentation which is a little bit inflammatory. So, put on, please, your thinking caps. Let's go through this, and hopefully we'll all get something out of it. I'm the grumpy old man, and today I will tell you why it's better to drink tea than do OOP. So let's begin. Can I please see your hands, whoever considers himself a software developer? Software developers. All right. Not too many, or some of you are afraid to get your hands up. It's fine. Okay. Who of you think that OOP is the way to go when writing a program, a project, or something? Hands, please. Okay, only 5. I will have an easy day today. Is there anyone who thinks that functional is the way to go? Like functional programming is the good thing. Okay, we have a couple of weirdos here, fine. All right, so I assume the rest of you are in favor of some archaic relic like procedural, right? All right, that's my guy there. You will not escape the fire. You will take flak anyway, so it's fine. Do whatever you want. Okay, so let's not really delay ourselves without further ado. We must all realize and admit that OOP sucks. Now, why is this that OOP sucks? Let's see. Let's go through a few quotes. And I am the first to tell you that when somebody comes to you and says, this guy said whatever, that's not an argument, okay? So this is basically somebody putting forward some kind of mythical authority to convince you about something, and that's not a real argument. Still, let's play this game, okay? I'm going to show you a quote. Object-oriented programs are offered as alternatives to the correct ones. Does anyone know who said that? Hands? Does anyone know? No. No. Okay. So, this was said by this fine gentleman, whose name I cannot correctly pronounce. Dijkra, I don't know how it was pronounced. He was a pioneer of computer science, amongst many others, the inventor of the homonymous shortest path algorithm, which you have all used if you have played any even slightly complex game in any computer or laptop or phone or whatever. Okay. Now, C++ is a horrible object-oriented language, and limiting your project to C means that people don't screw things up with any idiotic object model. So, anyone knows who said that? Sorry? Linus Torvalds, creator of Linux. Okay, things are looking a bit shaky for OOP there. Now, I am sorry that long ago the term objects was coined for this topic, because it gets many people to focus on the lesser idea. The big idea is messaging. Anyone knows who said that? Very good. Alan Kay, pioneer of computer science, the inventor of object-oriented programming, Smalltalk, Dynabook, and GUI. Dynabook, basically, for those of you who don't know, was the first actual laptop created, sometime buried in the annals of history in 80-something, in Xerox laboratories, and it was the first computer which actually had the clamshell form, which we know, with a screen, a flat screen, a keyboard, and a mouse. This guy was one of the people who made that. Because the problem with object-oriented languages is they got all this implicit environment that they carry around with them. You wanted a banana, but what you got was the banana, a gorilla holding the banana, and the jungle where the gorilla is in. Who said that? Anyone? Okay, that's a hard one. This guy, Joy Armstrong, co-inventor of Erlang. And basically, for those of you who don't know, Erlang is a language, a system, if you will, used in telcos and many other things, which provides 99.9999, however many nines you want, of availability, because it was designed to consider failure as part of the system. And of course, it also has the correct form of object orientation embedded in it. Anyway, I can go on like that almost forever. There are many other quotes available from computer science, software engineer pioneers. Why do they all say this? Because modern day object-oriented programming sucks big time. That's the reality. Okay? So, by the way, functional programming sucks too. But not so much, and for completely different reasons. Okay? But that's for another episode. Let's see now. What is OOP exactly? Unfortunately or fortunately, we don't know. Because, first of all, there are two things, the original concept and the current form of OOP. And what's worse about it is that the people who invented OOP have given different definitions depending on the time that they were asked. For example, Alan Kay, who made Smalltalk, if you follow Smalltalk's progression, you will see that it was completely different where it started, then it got a different form, and then it got another form, which also was different. And the definitions that they gave for OOP were actually different every time. But the most important, if you will think, is that there are two different things here which are called OOP. The original concept was distributed systems exchanging messages. These people coined this kind of system approach by observing nature, by observing proteins being exchanged between cells, and they said, wait, that's a good model, we can follow it. There was no explicit calling because the cells don't call somebody, they just put out proteins and other cells receive these proteins and do whatever they had to do. The same was true for the original concept of object orientation where you had objects and each object would emit messages without caring who will get this message and how this message will be handled. And of course, this is basically Erlang. This is a fine model that yielded the internet as we know it, because this is exactly what's happening on the internet, and it works. Right? Now, the current modern day OOP is a totally different thing. It's a way of writing software based on specific patterns. We will speak about patterns, they suck too. And it's based on 4 pillars: inheritance, polymorphism, encapsulation, and in general abstraction. This is a problematic paradigm which spawns disaster after disaster after disaster. Now, let's see OOP supposed benefits. I have split them into 2. The first ones are, the most taught things. That's what you learn. And these are some other things that I fished from the internet. Let's go through all of them and see whether they really are there, they're true or not, and what can we get out of them. So, OOP supposed benefits: code reusability. OOP is actually worse, if you get to think about it, because of the jungle issue. You write a very nice library, you have made your abstractions, you have piled classes on top of classes on top of classes, and you decide that you want the last class in the chain. So you get this, and now you got everything else with it. Now, you will say, sure, what's the problem? Well, the problem is that you now have a library, right, which is based on abstractions, and now some other person from another department goes and changes your base class. The base class still passes every test, unit testing, functional, anything that you do with it, integration testing based on that class, but your very nice abstraction, which is on top of it, now is broken. Have you ever had this happen? Probably I see some heads nodding, yeah, okay. That's the problem. You get the whole package. You don't get what you want, you get what is needed. And something else. If you can't reuse code while writing procedural or functional, then maybe you have a skill issue, because code reusability was always there, even from the 60s, even when they had those nice little cards where they punched holes in the 50s, they could still reuse the cards. By the way, do you know the term patch, where it comes from? Yes, they would put a band-aid on the card to block some holes so that they would make corrections to the software. Okay, that's where patch comes from. And code reusability was a thing from then. So it's not something that has to do with OOP really. You can do it anyway. Now, state management. That I could also have written as nightmare. Why OOP is worse than any other form of programming? Fragmented state. You have your state, which is basically two different things. One is for your local things to happen inside an object, and then you have the state, which is your whole program state, your data essentially, which you get from the input and you have to send to the output. And of course, everybody goes and mixes them inside objects and splits them inside objects, and now you have a state which is spread in God knows how many objects, and you don't have control over it because you don't really know how many instances of these objects you have, where they are, when they are referenced and from where, and who changes what. Especially in multi-threaded environments or concurrent environments, this is hell. And you have the problem of objects by reference. You think that you have an object, but you have a reference. What happened when this reference is gone for any reason? You get a core dump. What happens if somebody changes this reference? What happens if somebody uses this reference to change things in the way that you did not expect or in the time that you did not want to? Well, all hell breaks loose. You have heard a lot about encapsulation. Well, OOP encapsulation is fake. Why? Because you have getters and setters. When you have a state which is private, but then you go and create a getter, and much worse, a setter, now everybody knows your state and everybody can change your state. So you're not doing encapsulation. So you should have programs and objects which don't have getters and setters. But how can you do object orientation without that? That's a good question. We'll come back to that later. And some people think that, okay, so I don't have getters and setters. I create a nice little method which says, store how many pizzas I have on the fridge. You're still directly modifying the state. You have somewhere the number of pizzas, and you say, make that number X. It doesn't matter if it is set pizzas or whatever name you give it. If you go back to your code and examine it, you will find that a huge percentage of the functions that you have written are actually allowing outside people to change the state of your objects. And somebody would say, wait. That's bad OOP programming. You shouldn't be doing that. Fine. Go back to your source code and see how many times you have done that. And you will find a lot there. Why? Because it's impossible not to do it by the design of OOP, as we will see later. Simplifies debugging. Why would anyone say that? You have your code spread into a gazillion files, debugger jumps from page to page, your brain gets scrambled, you have to remember where everything is, what each and every class does, and somehow this is better? No, it's a nightmare. And even worse about testing. If you were writing functional, as people did in the 60s, in order to unit test, you would just call this function several times with different parameters, catering to edge cases, normal cases, that's it, thank you very much. How would you unit test the same thing inside an OOP project? You would have a class which would have this thing as part of it, and now you have to mock everything, classes which are used for this thing, subclasses, parents, whatever, create fixtures, and all the other stuff that we have to do every day in order to test one simple function. No, that's not better. Sorry. Something that I fished through the internet is that OOP offers enhanced security. For the life of me, I don't know why this guy said this. There is absolutely nothing that really enhances security in OOP. You can write a code in C, and basically you are a dead man walking, because C is a vicious beast trying to murder you every step of the way. Fine. But why would you think that encapsulating things into classes and writing the same thing in C++ would make it any better? It wouldn't. You just added some complexity on top of the vicious beast which is trying to kill you every step of the way. So, now, improved code. So, this is very different than that, right? That's object-oriented, that's procedural. Huge difference, right? This is so much better than that. Wait, it's the same. That is Go, but it very well could have been C with C++, would be essentially the same thing. No, if you have problematic code structure, it's your own fault. Sorry. But inheritance, yes, it sucks. First of all, if you try to program something which is even somewhat complex, you will end up at some point having cyclical inheritance. And you will burn your soul out trying to avoid this. Then there is the problem that if you are to properly model things, at some point you will end up needing multiple inheritance, which is not even supported by most languages, and those who support it really do a bad job about it because there's no way trying to do this correctly. And then the worse, the wrong paradigm of OOP, categorical hierarchies. This is so wrong. Why? OOP was actually, supposedly, created to model real life. So this should be the analog of real life, but it's not. Think of your socks. Where do you keep your socks? You keep them in a drawer, right? And the drawer is in a furniture of some sorts, and that's inside your room. And your room is inside your house, and your house is in an apartment block, which is in a city, which is in a country, blah, blah, blah. Okay, that's not categorical hierarchy. This is a container hierarchy. Life is created in the basis of containers, not in the basis of categories. I assure you, all of the mammals do not live in the same place in the planet. And no, there is not a place in the planet where all apple things are growing, right? Why? Because we don't live in this craziness. We live in the real world. When you inherit something from your parent, you cannot override their behavior. No matter how good person you are, if your dad was a bad guy, he will still be a bad guy. But here, the base class is somewhere, and then you have the inheriting class, and now the inheriting class may end up behaving completely different than the parent class. And yes, I know about Liskov. Thank you very much. I have read all of her books. She's a fantastic person. But how many of you have actually managed to follow her principles every time you write code? Okay, thank God I don't see any hands. That's good. So, hierarchies and inheritance are completely different in the real world than in this fantastic craziness. That's why most of OOP projects, when they start becoming really complex, they actually fail. And you need an army of engineers just to try to keep this thing going. And even the OOP people have actually abandoned it. And now they go for composition. Okay, encapsulation. But we discussed these things. It's fake. Why? Because you can have public state, because you can have getters and setters, and because objects are passed by reference, which means that you don't have any protection on the state. You pass a reference to 10 places in your code, and now 10 different places can change it whenever they want. That's not encapsulation. That's a little bit fake, or too much fake. And of course, there are also methods that affect the state, which we have all written at some point. And there is a very big problem that you cannot clone objects, because some smarty-panty people will say, yeah, but you could clone the objects and pass the objects, and now they're immutable and they're fine. No. Try cloning a file handle. You can't. It doesn't work. Deep cloning is unfortunately impossible to do every time. There are many things, operating system resources, file handles, connections, network, databases, whatever, which you cannot clone. Even if you do clone it, you will end up actually affecting the same data in the same state. Polymorphism to the rescue. Yeah, but it's not really an OOP feature. So polymorphism can be done through interfaces. Back in the day, you know, when dinosaurs used to walk the earth, we did it with function pointers. And even PHP can do it through magic methods. So, no, thank you. And it did it with magic methods, and it can do it with magic methods, even if you don't use the OOP features of PHP, by the way. So, yeah, nice, but no. Design patterns. Uncle Bob, he saved us. He gave us all of these nice things. The gang of four. Yeah, no. First of all, most of these things were actually created to save us from the mess that OOP created. Second of all, some of them cause other problems. And some of them are a little bit of a snitch. They tell us that OOP doesn't work, and it's not a good paradigm. Why? Because we have singletons. If OOP was so nice and so good, and if global state was a very bad thing which will destroy the world in a huge nuclear explosion, why do you OOP people have singletons? Because sometimes you need damn public state. A lot of them, most of them, are not OOP specific even. So the Gang of Four wrote their book in the mid-90s when OOP was the best thing under the sun. Everybody was OOP back then, and if you didn't know OOP, you were destined to die on some pavement without food. And that's what they used. But guess what? If you are a little bit of an astute observer and you start thinking, you will see that these patterns are very, very well usable outside of OOP. And some patterns are designed related, architectural stuff, which are not even code related, so OOP has nothing to do with them. So, yeah, thank you, Uncle Bob, but that doesn't save modern day OOP. So, what is OOP? The real one, which is a good thing, and it is messages. Now, this needs us to change a little bit the way we think. And unfortunately, most of you, if not all of you, have been spoiled by your universities, and you have been taught these things as being gospel. Thank God, when I started programming, there was no C++, and we were writing assembly in hexadecimal by hand. And yes, it is torture, I know. It left scars in me that will never heal, thank you, but at least we didn't go there. So, messages, but messages are function calls, aren't they? No. Not quite. The difference is the intent. When you're calling a function and you're programming a function which says do X, that's not a message, that's a command. You're asking somebody to do something. When you're writing a function which is this happened, this is something completely different. If you wrap your mind about this thing, you actually will see the light. Don't program in explicit way, you there go do that. Program in an event-driven way. This thing happened, handle it any way you see fit. How about when we need the result? Shouldn't we say something like, give me X? No. You should make a very big loudspeaker which will start screaming all over your code saying X needed in that place. That's a message. That's an event. We need this thing. Whoever is responsible for it, please give it to us. How? With another message. So is that it? That's why this talk was about? No, not quite. There is one other thing which you must understand. Simplicity. Keep it stupid simple. I'm not saying the real one, which is keep it simple stupid, because HR is here and I'll get fired. And what's the important about this? It is that you understand that the fact that you have a tool doesn't mean that you need to use it. Use the tool if and only if it solves a real problem for you that you cannot solve in a simpler way. You don't need to pile abstractions over abstractions. You just need to use the simplest form possible, because every line of damn code you write is a double liability. You have to support it forever, and it's possibly a bug. The fewer lines you write, the fewer structures you pile on top of other structures, the less liabilities you have. Does this work? Yes. More things in the future. And it's reflected also in the bill of Google Cloud Services, because now we need less pods to do the same kind of work. Unfortunately, you have to go to the mirror, look at it, and tell to yourself, I am spoiled. Because all of you, or most of you, are now used to cut a slice of Kubernetes, get 20 pods firing, and yeah, sure, it doesn't matter, let's light our money on fire, because if we write shitty code, Kubernetes will save us. Sorry, that's not programming. That's basically copy-paste of existing stuff. That probably makes you maybe a software developer, but if you want to be good, you have to be a software engineer. You have to engineer things, you have to measure things, you have to be very aware of what you're doing. Not nilly-willy writing code, not going to ChatGPT and copy-pasting, as is the norm now. By the way, ChatGPT sucks, and you're welcome. Thank you. So, now I hope I have inflamed a few of you. I hope I gave you something to think about. And I will gladly answer any questions you may have.
Thank you, Yanis, as usual. I always enjoy your jokes. Thank you very much, special. Okay, any questions?
There's a hand there.
Okay. I see. I'm going.
Thank you for the talk. And you haven't explained me because it's very similar to the talk I give to the new people I hire. But you mentioned this. You mentioned the performance, and I would like to add something. Whenever you do any virtual call, you do a stall on your pipeline of a CPU. It's a 100% decrease in the CPU performance. Just don't forget about it.
Guys, you're supposed to disagree. You're not supposed to say the same things that I said myself. Come on.
Please disagree. I really love it. Okay, who's next?
Yeah, so I wanted to talk about the last comment you made. You talked about GPT and how using it will make you a bad engineer, right? I think I disagree with that statement because...
Good. Go.
So I think I disagree with that statement because I understand that, you need to, as a software engineer, you need to find a way to, engineer things, think for yourself and all of that. But lately, people have been working with, AI-driven development, which I feel like it makes things faster. AI can actually make you think. I believe there's something they call prompt engineering, right? Which is about prompting AI, right, to do things for you, right? So using ChatGPT, I feel like it doesn't necessarily make you a bad developer, but probably makes things easier for you. So
Okay.
I think I just want you to clarify.
Okay. All right. So first of all, this is an inflammatory presentation, obviously. Some things are pulled from the hair to make you cringe a little bit. And yes, ChatGPT is not useless, of course. I mean, it sucks, but it's not useless. I'm joking. So, why did I say that? So, it's a very different thing to actually ask ChatGPT for an idea, which you will then think about, make better, use, whatever. It's a very different thing to actually ask ChatGPT to fill in some boilerplate functions, which are always the same, and you can't be bothered to write this thing for 100,000th time. Okay, I get it. ChatGPT can be very helpful to do some sort of initial testing for you. Also, very useful there. But why I said that is because take testing, for example, right? ChatGPT will give you the norm. So it will give you the standard stuff. Some fringe cases a little bit, normal stuff, you will get a normal, nice little package. But testing is not supposed to be that. Testing, you need to actually push the system to the limit. And ChatGPT does not do that. It's useful. I am not saying that it's not useful. I will never say that somebody who's using ChatGPT is a bad engineer. No. What I wanted to make clear, if you will, what I wanted to tell you, is that the bad thing is when you rely on it, right? When it becomes your crutch and you cannot walk without it, then you are in the wrong side. Okay, if it's not a crutch for you and you can do everything you want, even if ChatGPT would disappear tomorrow, and you know how to use it, and you know how to fix its results, which are mediocre at best, yes, then it's fine. Okay.
Sorry. We have a video translation, and I suggest to use microphone to be sure that people online can hear us as well. 1 minute.
I was saying it's like having the IDE do the code formatting coloring for you, which is really nice, and you can see what it's doing. It can do the nice indents for you, but you shouldn't rely on it to actually make you understand the code in the first place. So if you want to have it auto-complete your function or generate a function, that's great. But you shouldn't trust the output unless you have the skills to know what the function is doing. And I think that's like a big difference kind of thing. You can say, I want to put a prompt in and say, oh, can you generate me a function? So I'm trying to do this, but you still need to interpret the results as a human to test the output of that properly before you think this tool is gonna, it's good to accelerate your development process, but it's not good to say, oh, I'm just gonna rely on it without blindly testing the output. That's kind of where I sit on this.
Yeah, I think this is a fair statement. When you will get in a dinosaur-like age like myself, and I mean in the programming world, where most people nowadays retire at 40-something, that's another craze, you will see that actually simplicity is key. And sometimes going through this whole process of getting the ChatGPT to write the code for you, then go through it, fix it, whatever, is slower than writing 3 nice, simple lines of code that do the same thing. Again, I'm not against ChatGPT. I'm not against AI. I feel that it's overhyped, and I feel that it's used wrongly as a crutch to people who should learn to walk by themselves. That's what I wanted to get out there. Any other question?
Yeah, so thank you for the talk on ChatGPT. And I'm actually curious about, so there is some stuff that functional programming gave to us as well, right? Like more strong type systems, and also like some ideas that are incorporated in modern languages, like you also briefly mentioned interfaces, right? Like Go has interfaces, Rust has traits. So I'm actually curious about your opinion on those. I can't say I disagree with what you said. I'm just curious, do you think that they add more to the mess, or they actually solve some of the issues with OP?
Okay, so I think that they are tools. If you know how to use them, it's fine. If you end up cutting yourself, it's not fine. You can get in a complete mess by having a huge array of interfaces where you lose the ball and you don't know what's happening where. You can't even do that. Interfaces are specific tools. They are part of the concept of abstraction. You need abstraction to do some things, for sure. Interfaces are a good way to do it, but they are not the only way to do it. If you know how to use them, by all means, it's fine. I use interfaces every day. We happen to write Go these days, and interfaces are everywhere in our code. And since I said something about functional programming before, I said that it sucks. Well, I'm an old man, everything sucks for me. But yeah, functional programming has its own problems. The two most important ones for me is that if you want to do functional programming correctly, you basically need to be a mathematician. And the second thing is that you cannot have purely functional programs, because I/O, no matter what you do, there will be a fringe in the periphery that you cannot be functional. So it's not the do-all, solve-all kind of thing. What we are working right now is 90% I/O, so basically, even if we wanted, we cannot use functional, okay? And the last thing is that under certain circumstances, functional is so painfully slow that you cannot use it. And if you want a proof for that, go in the outside world and find one game which is written in functional way. You won't.
Okay, before next question, I'd like to emphasize, if you are watching us online, feel free to ask questions. We will read it.
Hello. So I don't have any questions, but I would like to make some inflammatory comments.
Fantastic. Go.
So the quotes from Linus Torvalds, he was criticizing C++. And yet C++ is almost like native language in Linux.
No, that's not correct. That's not correct. C is the native language of Linux,
but
not
C++ is very much supported, and it's like
Yeah, but the kernel is C.
still. Also, Dijkstra was criticized in OOP, but he was not a programmer, right? So I also can criticize some things for it.
I mean, okay, yeah, that's
Don't
a
work.
little bit far-fetched. Yes, he was not a professional programmer. He was not working as a programmer, but trust me, the man could write code.
He could, but yeah, like for example, in my case, I used to work with C++, and
Me too.
Oh, condolences. Yeah. But for example, there is this virtual inheritance, and of course I could criticize it and say, it's useless, because I've never seen in my entire life that somebody uses it. But I don't criticize. Maybe somebody uses, if they need or whatever. But unless you really need it, you just should not use it, and that's it. And that's.
I think that's what I said before too, yeah. We don't need OOP, just don't use it.
Thank you.
Do we have any more questions? No? Okay.
A small one, actually. We've heard a lot of skeptic ideas. So who is the good guy in this case? So OOP sucks. Functional programming is too complex to be.
It sucks too, yes,
True,
please.
yeah. So yeah.
Okay.
So who is the savior? Who will save us then? Who comes and?
So, yeah, of course it sucks, yeah. So that's a good question. In reality, you can write good code in any language. It's not about the machine, it's about the man. That was told by Chuck Yeagers, the first person who flew higher than Mach 1, the speed of sound. He said it's the man, not the machine. So essentially, you can write OOP code which is good if you know what you're doing, right? Of course, you need to write old-time OOP, not modern-time OOP, but we analyze this a lot. Okay, yeah, you can write even in Java and do something good. Which Java sucks, by the way, with all the annotations they have put in. It's crazy, but anyway, so assembly is scarring your soul to oblivion, of course, yes. So what is there to do? Well, the cynical me will answer nothing. That's why we programmers have all of these psychological issues and spend our time in front of a monitor during the night, okay, and sleep in the morning. But if we want to put some sort of, nice touch to it, you can write good code any way you like, as long as you understand what you're doing, as long as you're not overdoing it, and just that OOP really helps you overdo it. Okay, there are other paradigms. For example, modern Go, like Golang, right? The way it is now, not in the beginning. In the beginning it was a little bit useless, it sucked. But now it's a little bit better, and you can write code which is really simple, really fast, and it doesn't allow you the stupidity of all kinds of inheritances and structures and abstractions and everything. And you can do something good there. Can you write exactly the same way while writing C? Yes. C++? Yes. PHP? Yes. Java? Yes. Yes, you can do it. You just need to be careful what you're doing, right? Don't overuse things.
Less is more.
Yeah. You don't need a factory to produce something which you use only in one place.
Thank you very much. Well, I hope, no. You know what I suggest? I'm afraid there are a lot of questions to Yanis. Let's agree, Yanis will be here. And during break, everybody can
Okay.
ask all questions. Sorry, Yanis.
No eating for me today, thank you.
Great. Thank you very much. Let's have a break. 10 minutes and 7:33. I'm waiting you here for the next presentation. During these 10 minutes, yeah.
Thank
you,
you.
Yanis. We have a lot of finger food, we have a lot of drinks, and we have toilets, which is very important as well. Here and in opposite of food. In 10 minutes, I'm waiting you here. Are we ready to continue? Well, to be honest, I'm so excited that you have a lot of emotions, you have what to discuss, and of course, it's the main purpose to discuss. That's why I'm really sorry to interrupt you, but we have two more amazing speakers, and please believe me, you will have what to discuss after their presentations as well. And well, I have an opportunity to talk a little bit. I'd like to use it. You know about what I'd like to say. Everybody can be a speaker. I mean, here there are a lot of people who already have been speakers here. Thank you. And I hope it was not only one episode. I hope you will be speakers in the future as well. Yes. Thank you. And if you have never been speaker, it's okay. You can always apply to be a speaker, prepare a presentation, and it's an amazing opportunity to share your thoughts, to share your ideas, and maybe to take with opportunity to talk with people. Okay, it was a minute of advertisement. And now I'd like to ask Luke to continue, our next speaker. Please welcome Luke.
Hello, I hope I can be heard. Okay, so once again, welcome. So today we are going to be talking about the modern backend. And by the previous speaker asked how many persons here are engineers, and a couple of people raised their hands. So even if you're not an engineer, there's no problem. I think I'm going to try to break it down for everyone to understand. So. Before now, the way projects were built is simply the monolith structure, in the sense that everything will be on one code base. And still today, some companies still use that approach. Some companies, they still use that approach in the sense that because they have legacy code that they have to maintain and all that. But as time is moving forward, companies are adopting the modern day backend structure, whereby they have microservices. And even if they have a monolith structure, and they will tend to be pulling off some services off and be hosting those services and deploying those services independently. So we're going to talk about how the modern day backend should look like. That basically stream processing and messaging with messaging pipelines with Golang and Kafka. What a wonderful combination. And the previous speaker was saying something about OOP, and I just want to add, if you're not into Go here, obviously Go is not OOP oriented, like it doesn't have OOP, but with the use of interface, you can create some abstraction to actually still use the OOP concept, but by design, Go is not OOP oriented. So a little bit about myself. My name is Precious Ndubisi Luke. I am from Nigeria, and I'm a senior engineer. Currently, pursuing a master's program here, but the last place I worked like a few months ago before I came here was Utopa. It was a payment company in Nigeria. So that's just about myself. And on LinkedIn, Precious Luke. So yeah, let's get started. From the topic, I'm going to introduce some concepts. From the topic, we talked about Kafka. And what is Kafka? Basically, Kafka is a distributed event streaming platform that publish and subscribe to streams of events, e.g. clicks, transaction, and store event durably and process them in real time. And I will try to explain this. If basically, let's say we have a basic user registrations that if you have a website where user will have to register, the things that happen under the hood is this: when the user fills the information that he or she has, to maybe email address, phone number, password, and all that. Ideally, what happens is you tend to send them an email. You tend to get their information and register them on your database, and you tend to move them to the next stage, which is they'll have to verify their email to confirm that the email is valid. So these are just the steps that happen when you're building a user registration process. So I would try and relate it to how it relates to Kafka and how Kafka can help you streamline those processes in the sense that you can have independency, like just have independent structure. The service that is handling your email service can just be independent from the service that is actually registering the users in the database. And this is just more like a watered down explanation. So Kafka, what Kafka does is this, and it helps to actually handle these streams of events in a better way. I'll come back to this. So there are some key features of Kafka. It is designed to handle a whole lot of events in milliseconds, and it is built for fault tolerance in the sense that if a particular service fails, it has a mechanism to actually retry that service. And just like the example I used, a user tries to register on the platform, and let's say the email service is bad, or for whatever reason it fails. It has a way of retrying it, and this does not stop the process of going. This does not stop the other process of going on. The user still gets the response that you put out for him to get. But Kafka has a way of doing this under the hood in the sense that you just don't have to worry about code failing from the way most of us were used to, which is the monolith structure, in the sense that if a process fails, it affects other process, or if a server is down, that means that that particular service cannot be accessed. But with the use of Kafka, if a particular server is down, if a particular service is down, it moves on to the next one and helps you go ahead with it. So another key feature of Kafka is smooth running. Broker is just a term used for also a server. If you're deploying Kafka consumers and all that, you can have multiple brokers in different servers. And when a topic gets sent to the consumer, if this particular partition is failing, it can distribute it to the next partition. And if to the next broker, broker is a term in Kafka, it's just another term for servers. So it's built and it handles horizontal scalability in the sense that the more traffic you get, you have the ability to scale your probably more brokers to host more brokers. There are some key concepts about Kafka. If you're new to it, or if you've probably into it, you would hear words like topic, broker, producer, consumer, partition, and replication. So this is just a basic image that tries to explain these processes. A topic is more like an identifier. What sends the message? Like identifier, what sends the message? This is just how it works. It sends the message to the Kafka cluster, and it gets broken down to different brokers. And this also gets split into partitions, partition 0, partition 2, depending on availability. And this can be decided based on whatever thing you define. Maybe customer ID, depending on what you're building, customer ID, transaction ID, or user ID. And this is just a service that you can host that will just send the messages to the brokers. Then the brokers will just send the message back down to the consumer. The consumer will interpret and give a response or act on what you want it to act on. Just for instance, the example I gave, user registration, which is you can just decide to have a different service that's handling sending of email to users. Another service that is making sure that those the users, when the user registers, his or her information gets stored on the DB. If if anyone fails, it doesn't matter. If anyone fails for any, it doesn't matter. The next one will be done. And this happens like almost instantly in the background. It does not really affect your response time. It happens on the background and it doesn't affect your response time. So, just like I explained, brokers are more like servers. You can have multiple brokers in different places, AWS, DigitalOcean, depending on where you want to host your brokers. And it's not really a rule. It's all, what matters is what you're building and how you want to do. Producer, like I explained in this image, it's what sends the message to the Kafka cluster, and more like consumer gets subscribed to the producer's message and gives a response based on what you've defined. And we have partition. When a message is sent from the producer to the broker to the server, it gets split into partitions. And I'll come back to this. I just did this basic image. This is Kafka topic, and once a topic is being sent and it comes down partition, and it can send it to multiple brokers. On that time is servers, and depending on availability, for whatever reason, a broker may fail, then the next broker will take effect. So it has fault tolerance. It doesn't. It makes sure that what you're doing is going to work perfectly. Which comes down to still replication. So the next now, why is Kafka so great for modern backend? Why should you look in this direction? Why can't you just stick to what you already know, what you're doing, and what has been working for you? First, it has the coupling. Like microservices can communicate independently without direct dependency, like without having to depend on each other, or without having to, just like we have in the monolith structure, where if a particular service fails, it halts the process. I know some persons may say that there are still ways you can do that in the monolith structure, but what happens if your server gets a whole lot of traffic and that particular service is down? But with the coupling, you can have have a separation of concern based on services that are getting a service may be having a whole lot of traffic. You can decide to decouple it, microservice, which is the modern way of doing it, and there is a real-time processing. As events are coming in, they are being processed instantly. It has durability. Events are stored for days, years, and they can be replayed, and it can be scaled. I think I mentioned scalability. It can be scaled horizontally. The more your traffic grows, the more you can have more brokers, servers that will handle that. So why Golang with Kafka? Just like the topic says, why do we have to use Golang with Kafka? Is it a must? No, it's not a must, but Go is simple. It doesn't give you the headache of other languages. It's just simple to learn if you've not used it. By design, it has concurrency inbuilt with the use of Go routine. It can handle thousands of requests, basically consumer and producer. Performance, once it's compiled, it's not good code that is being run on the server. Once you compile it to the executable, that makes it a whole lot easier for your server to read. So it increases performance. And if you check online, there are some benchmarks that if you write a particular for loop in this language and write in Go, same function and all that, Go is always faster in most cases. Simplicity, easy to learn. It's just once you get the hang of the syntax, it's something that you can just work with. One of the founders of one of the people that did Go at Google, one of them said that Go is simple. If you just sit at it for like a week, and you'll be able to build something reasonable using Golang. And why do we need to use Go with Kafka? Because there are a whole lot of library, production-ready libraries like Sarama, which was originally owned by Shopify. I think IBM they've transferred ownership to IBM. And there's Frank Go, there's Confluent Kafka, that is also popular. These are nice Kafka production-ready client libraries that I can use to work with Golang. So, why is Go? Why Golang is perfect? Is Kafka's perfect partner? Concurrency, resource efficiency. By resource efficiency, it has been proven that Go programs, they consume less RAM on the servers on your machine, and rapid development, no dependency hell. You don't go by design. Most of the libraries you're using, it's mostly built by Go. Like you don't have to. There are still libraries that other developers have done, tools and all that, but by design, Go has bundled everything that you need to just get started. You don't have to start importing a whole lot of libraries like you would in other languages. Resilience by design. By this, it is just like we know, it is meant to handle. Meant to handle a whole lot. Like since it's not like other languages, it's a compiler language. That means that before you even get to deploy your code on the server, if there's an error in the code, it won't even compile for you to deploy. So you'll be wondering, the modern day backend, why do we need that? And where does Kafka and Go, where do they come in? They come in so many places. If what you're building is really event-driven, say you have a trading or sporting site that a whole lot of data are coming in simultaneously. Ideally, if you haven't known this approach, you want to handle that with RESTful API, but that will be a whole lot of performance issue, because having to listen to those, make those calls, you're just putting a whole lot of work on the server. So Kafka and Golang, they transform industry in financial area like stock trading. Kafka can handle up to 10 million trades per second. And Golang, it has ultra low latency, order matching. What does this mean? It boils down to the fact that it doesn't consume much resources on your machine. It's really, really efficient for high traffic websites, applications also. Then another industry that Kafka and Golang can transform, it's retail and logistic industry. Dynamic pricing, Kafka track competitor price, inventory levels. Go can adjust price in real time using machine learning models. And this is not me trying to, you can say I'm trying to sell you Go and Kafka. Obviously, there are other tools that you can use to achieve the same thing. But from my experience, Go is better, and you should give it a try. And I bet you will not come back. So, call to action. How do you get started? How do you get started doing the backend, using the modern backend approach to build your stuff? first of all, you just have to, if you haven't used, you just have to like get your hands dirty, experiment, build things. You don't, obviously, there's Docker Compose, just pull off stuff and just get started. Build, there are a whole lot of tools that you can use to monitor your traffic, and one of them is Grafana, and that is really a way of actually telling you where your traffic is coming into, how the responses, the time and all that. You would observe that Go and Kafka, they tend to handle things pretty much okay. And you scale, deploy more consumers as the need arise. Basically, more brokers, more servers, deploy as the need. The more traffic you get, the more the need for you to deploy more consumer. So basically, I'll come back to this. I'll tell you a personal experience that I've had. When I got into programming, the first language I had to learn was PHP. So after PHP, I did it for a couple of weeks, and I started using Laravel and all that. So a friend of mine introduced me to Go. Based on, this was like early 2020, and I was saying Go is simple and all that. For the fact that I have a PHP background, that was the first language I learned, and looking at Go syntax, it seemed a little bit different from what I was used to. But the minute I got the hang of it and started using it, I had to start comparing things I was doing in PHP, how fast and efficient they are in Go currently, as to how they were when I was using PHP. I still use PHP, obviously, but I tend to build a whole lot of microservices using Golang. So the fact that it has concurrency inbuilt, something that PHP doesn't have, that is what really amazed me. And resource efficient. You can just deploy a Go program like you don't even, if you're just starting out, you don't have to spend so much money on servers and all that. The list a program that would need you to use like 4 gig RAM on the server on DigitalOcean or something, it can work efficiently when you're on 2 gig RAM if it's written in Go. Because Go minimizes, has a lot of performance. There's a whole lot of things that it has taken care of for you by design. And it speeds up development because it doesn't have the whole OOP concepts like classes, inheritance, and all that. But it helps to like speed it up. Just do what you want to do, test and compile and deploy. So I guess it's a short one. That's what I have. So I do not know if anyone has any question to ask or contribution.
Okay. Okay, Sim?
You mentioned that Kafka, if I'm saying it right, like remembers for many months. What does it use to? That means without the help of a database? How does that work? Is it some form of inbuilt caching or?
It's something that, okay. I was trying to look for that. Events are stored for days and years. They can be replayed. It all depends on what you are trying to achieve and how you want this event to actually play. You can decide to like write it in a way that once a producer sends to a consumer, it should respond at a later time. That works. So I don't know if it's clear enough.
Okay, I think I misunderstood it before. Okay.
Okay.
Great. Do we have any more questions? Okay. Great. Thank you very much for your presentation. Thank you.
Thank you.
Well, now we have 10 minutes break, and at 8:11, I'm waiting you here. We still have a lot of food and drinks. Usually I'm always very shy to interrupt all your fantastic conversations, but honestly, please believe me, our next presentation will be really amazing. And I'd like to introduce David. Thank you very much for being speaker today. Welcome, David.
Thank you. Hi, am I coming through? Okay, good. Great. So, there we go. So, funnily enough, although we did not have an agreement or any sort of meeting between us, it's going to merge very much with what Yanis and Precious were talking in one way or another. The discussion is about going from complexity to clarity, and that's not always an obvious way around how growing in companies, how the technologies become assimilated and more complex. Now, who am I? So my name is Dave Saliba. I'm the director of, I have many names in my company, but one of my official titles is Global Director of Technology. I've got more than 30 years, so I'm pretty much a dinosaur together with Yanis about this. And yeah, I'm from the Paleolithic region here, Mesozoic, I think. And so this, what am I bad at? I'm bad at networks. I'm bad at front-end coding, so don't ask me about React and Vue and anything of the sort. I'm bad at keeping my opinion to myself, as in everybody who knows me will be able to vouch for. I am good at a few things, which is mostly system integration. I've worked over the years on many technologies. I'm quite good at getting to know what technologies are used in a company, even from scratch. I have experience as a development, as system administrator. I've had experience in C# and Java and other things. And also, I have experience with robotics and IoT and stuff like that. These are what I did till now. So many years ago, where I met Konrad, where I used to work in Method on robotics. Then I was again with Konrad on some microsystems in Panta. Then I was a C# and Java developer, became support director with 2X, sysadmin with BetClick, head of infra, because I forget them, I'm in so many places. Head of infra with StreamAMG, and now I'm working for a great company called Karma. So I've got some representation over here. So I will try to inspire some ideas in you guys. Most importantly is that, as Yanis said, I'm going to kickstart off ideas that he already exposed without asking my permission, but okay. Why simpler systems often lead to better outcomes? I'm not going to mention object-oriented programming, so that's fine. How clarity bleeds cleverness. That means how being clear in your what in Java you would call something like an interface, how you would call it in other languages, you would call it, for example, function declarations. How the clarity is much more important than how smart you are doing a triple pointer in direction in C. It doesn't matter how clever you are, it's important that the person who comes after you can understand what he's reading. That is way more important, and especially to companies. From a technological point of view, we like to show how good we are at what we do, and that ties into how good your skills are, and we all understand that. But at the bottom line, what's important is that when you write something, when you make a piece of code, when you implement a system, you are building a system. If architects had to think like the IT crowd today, we're building and rebuilding all our buildings around us every 3 years, every 4 years, tops. So we need to think more in the architecture engineering perspective. Elegance and restraint is another important thing. Keeping back from, again, as Yanis mentioned as well, I'm going to point out a lot of things that you mentioned, Yanis. Keeping back from jumping on any new idea that comes along. Evaluate, play with it, use it in small projects on the side till you really gain confidence, understand how the market goes. Then start thinking of using it in a business. Think you are a Formula One car using physics rather than you are a Fiat in a production trying to get the cheapest possible production for a car that will last only 3-4 years. You want to win the race, you want to get the business. Preferably, if you're using physics well, the technologies you gained today are going to become your legacy in the future, rather than next year we'll make another car completely different. We have to start getting that a bit more in IT. I feel it lacks the legacy idea of I'm building something for the future. I'm building a system that will last 10 years, 15 years. I will not try to tell you what you do is wrong. I will not try to sell you anything. Teach you how to do your work very differently. Maybe I might give you a couple of hints on that. I'm not going to rant about the good old days, because that's already been done. So. No offense. All technologies. Okay, this is important points. I believe they're important points. All technologies that we use, all of them, and it's the simplest thing you see around you, has been engineered by somebody who probably knows much more than you what he's doing. No matter how smart you are, even if your IQ is 140, 150, somewhere along the lines there was somebody who had either more time, more IQ, or much more dedication than you. Learn to leverage those technologies and those ideas. Don't try to go with the latest fad because that is the fashion. The complexity that comes in every product that we use is much harder, much more than we expect. It comes with good things, comes with bad things. We do have a lot of tools already at our availability inside our operating systems. I'm giving you a bit of an idea of what's to come in the discussion, but most of the developers I meet today and that we employ in our company, and in many companies that I've seen, have no idea how the operating system works. If I talk to them about what features your file system has, they would have no idea, and you're developing it on a computer. We ended up in a world where system administrators are getting so abstracted from their hardware, they don't even know what the post is anymore. They don't know what their server does when it powers up because it's somewhere on a cloud. And we have developers who do not know how to develop in C, don't know what a pointer is. And that is a problem because those tools are powerful. They were good enough to drive the banking system from the 60s till today. I'm not saying go work in COBOL, it's not my point. Although some people might say that you'll become much richer that way. Remember the year 2000, anybody here? Learn the difference between the engineering approaches and the ITCS approach that we've been taught. Universities failed us all, including myself when I did my degree 10 years ago. They taught me nothing about a practical operating system. It's all in theory. What are the tools the CPU has? What are the tools the operating system can expose? Understanding those will give you an insight into choosing which technology to deploy on which system and why. Does this work on ARM? Is Postgres good on Mac Silicon? Why? Does it have the right features? Does the CPU expose the right things? Does the API or the system calls, do they transfer the right efficiencies to the software that you have? We always assume that the stacks have been written so well that everything is going to work perfectly throughout the ages. Reality is that when you start looking at how any company, including Intel, including AMD and ARM, and all these, when they do their benchmarks, they're all the time tweaking all the buttons to make the software look like it works really good on their system and not so good on the others. So the best program is no program. Simple as that. If you can do it in Bash, and it works fine, and it's fast, why do you need to write software for it? If there's a script that will do it super fast using ready-made tools like copy, move, and that inside your operating system, why do you need a language? I mean, why do you need to write using libraries that implement maybe a version of copy that is not aware of the underlying operating system? Use the copy that the operating system comes with. When there's an update, it's going to be better. When you have new hardware that can use the right messaging protocols from, I don't know, fiber channel in the olden days to other new technologies and SATA, when it does dynamic memory allocation, it will be able to move a file much faster than if you try to move it reading 1 byte at a time, because unfortunately JavaScript has no idea what hardware you have. Okay, then that one is obvious. The less lines of code, the less the probability of bugs and unforeseen effects. I don't think that's kind of an obvious. So, the landscape of the, this is just the IT cloud native tools that are available out there. Yeah, you cannot see them, and there's no way I can ever show them to you. There's just too much data. That's the point. That is just the list. Those are the companies, not the products. Each one of these might have 3 or 4 products. Apache is one of those. Do you understand what problem you're going to have every time you try to employ somebody and tell him, listen, we use this, this, and that. And he says, I never saw them before. You say, yeah, tough luck. You're going to spend 6 months here being paid trying to figure it out. And then if you don't like it, go find somewhere else. That's what probation is. This is just software landscape, and these are the data stacks. I'm not even talking about libraries. These are data stacks. This is like MySQL, just to give you an idea. How many do you think are going to be able to master all these tools all the time, keep them up to date, understand them? Absolutely, probably mine, negative, I think, because somebody will be failing before he starts. There's no way that we can catch up with all this zoo, I call it. It's a zoo, it's just impossible. Every company you talk to, they use different stacks, different techniques, different knowledge, and nobody knows the basics. Nobody, very, very, very few. You can count them on your hand, usually in a company of 400 people, you count 3 people who know C. 4. So what's the good in these pictures? Well, lots of choice, lots of bells and whistles, lots of different tools. There's going to be many, many things that all these companies believe they found a niche that they want to fill. They believe there's something missing in everybody else's product, or it's too expensive, or maybe ours is free. Oh, when it's free, as usually, we all know now, you're the product. All of a sudden, consultancy fees. Oh, you need to go to enterprise to get that feature. All of a sudden, you're tied in with their libraries. Their libraries are not open sourced. This is our special protocol, because transferring data from one computer to another through a piece of wire did not exist 60, 70 years ago. They invented a new protocol in the year 2025. And the problem with those pictures is that that complexity of learning is unfathomable for any company to choose which thing. So most of the time becomes either a CTO who doesn't know his job very well and gets bamboozled by somebody at a networking meeting and tells him, why don't you use ours? It's much better. We'll give you a good price. Or if it's free, it's free. So we all love new toys, yeah. That's the elephant in the room. It's a cute one. Yeah, feed your eyes. So, yeah, that's, by the way, AI can do this, all right? Small barb. So trust me, I get it. I do believe very, very much that learning all the new technologies that are available as much as humanly possible. I sleep 4 hours a day, and anybody here who knows me knows that at 6 o'clock in the morning I'm still working. So it takes a lot of dedication to try to figure out what you want to do with your life. By the way, those lists I showed you before, these don't make it any easier at all. So, the difference between the traditional tools and the tools we use today. Traditional tools, I mean manual tools, right? We all know that if I have 3 screwdrivers and I buy a new one, I do not need to fight with my other people which screwdriver we're going to start using. Tools pile up, and they become, the more tools you have, the more options you have on what you're going to do. But in reality, in a company, our tools need maintenance, need support, needs continuity, needs updating, needs debugging, needs consultancy, all sorts of problems. It's a very different thing from what we naturally have been doing for hundreds and thousands of years. Having tools and hoarding tools till any problem that comes our way, I have this spanner, I have this hammer, I have that. If I don't have it, I go buy a new one. So it's going to take away the functionality I have from my previous hammer. I have 2 hammers. Doesn't work like that in IT. There's too much work that goes into each and every product we use. So this is the languages Tower of Babel, by the way. You know what happened to the old one. Now, I'm not saying that the most popular language is the best to use, but the most popular language is the one where if you're starting or you're trying to discover which languages are going to get you a job, look at the top of the pile. And if there's an old one up there, that's the one you want to learn. The older, the better. So this is the top of the pile. Now, HTML, CSS language, it's not your incomplete, nobody cares. Well, it is useful. Try getting internet before HTML. You remember, you don't know what a Gopher... You know what a Gopher site was? Then we'll talk. Python is an amazing language that is as slow as, I don't know, like driving reverse to go forward. But the libraries that come with Python are incredibly well written. So I mean, you cannot diss it too much. But those libraries were all written in C, so, you know. And yes, by the way, I don't know who said it, but yeah, Linux, the kernel is 99.9% C, and some of it is, they try to put Rust. C++, Linus Torvald kicked it out ages ago. They tried it for a bit. He hated it. Everybody else hated it. Doesn't work. So I agree 100% with Yanis on that one. PHP, yeah, it's a bit of a dying beast, but many companies like using it. PowerShell is not a language. I don't know why they put it in there. Because with that argument, Bash is a language. PowerShell is not. For me, PowerShell is really a scripting language. Yeah, this again is done with AI. Look how many mistakes it's got in it. It's incredible. But it will get better. Now, I'm going to give you 3 case studies, and I'll go through them quickly because I think you don't really care about the details. But the idea is to explain longevity, simplicity, and an engineering approach that sometimes might help you. I'm not saying it's going to solve all your problems. It's going to solve maybe 5–10%, and if it's done, happy Christmas. One of the first problems we had that I had solved using a very different approach than everybody else was suggesting some years ago was an auditable archival filing system, hierarchical. And yeah, this is made to sound complicated because that's how you get your requirements. So that is on purpose. It's not because I'm pompous. I am pompous, but that's another story. Hierarchical indexing, speech-to-text, and metadata tagging for court systems to allow reviews of cases for records. So the challenge is a multi-decade lifetime archival system. Try to do that with Kafka, by the way. 2.4 years is your total coverage of life support. So every 2.4 years, you're going to rebuild your if Kubernetes still exists by then, by the way. Because SSH will be there in 30 years, I promise you. Kubernetes will probably not even be a word on anybody's mouth. The challenges of multi-decade lifetime archival systems. Multi-decade means that in 10 years' time, the court system will not have money to make a refurbishment. They'll be still running the old system. They must to make sure it's still updatable, working, configurable, and whatnot. Features. All right, facilitating, searching multimedia files, courtroom videos, police interviews, and all that stuff. Please. Automated speech to text is something modern, which we got thanks to AI, OpenAI. Whisper, which is a free system that can basically help you translate anything. So the process is simple. A new file is dropped, the operating system recognizes that a new file is dropped. So with one line of code, you have an event loop, one line of code in the operating system, beats having V8 running there just to have Node.js monitoring a file system to connect to the OS and ask it, is there a new file? Use the OS. Tags can be written into files. Many people forgot completely that your operating system has a tagging system. Like there's metadata that is connected to files, and you can drop files near files. They're called sidecars. A JSON file can hold all your metadata. That means no databases. You have 1 million files, 1 million entry JSON. Fits in RAM like a butterfly. We have 64 gigabytes on laptops today. It's a simple implementation. You put in your data in simple folders. The names are given with a meaningful way. And now everybody's going to tell me, so how do you get views and how do you make queries? Soft links. Something that any Windows user, by the way, used to call shortcuts. But in Linux, it's a real thing. And soft links is a way for you to expose a file system in a different structure. Many people use it for very basic reasons and forgot that you can build a whole view support structure with that. Metadata, a file per file. Basically, you have a file which gives all the metadata regarding that file. You need that file, you know the date, you know the judge that was presented by the file system. You have a file near it with the metadata. Do you need a database yet? I think not. Not yet. Files per folder, these store the data of those folders. Maybe you need to say, okay, this one is a low tier, low priority, this is top secret, this needs to be accessed by these people, and then you have user access and all those features built into your operating system, which you can leverage with a few scripts. The transcript file looks like this, and it is done literally with, back. So the transcript file would be the result of a single line call processing the video file, calling something called Whisper. You just literally pass the name of the MP4 and say output to this file. You get the text in that format, more or less. The names of the speaker recognition is not yet 100% working, but it should be getting there in a couple of years. Extended attributes. These are the attributes that I was mentioning where you can add metadata inside a file. So you can search your files by those attributes in the operating system. Haven't touched the database or any connectors or any object-oriented programming or any complex languages yet. Script to create alternate views. That's all your code, basically, for indexing and adding new tags. And if you want to revise your file system and add a new view, you're going to do it on a database. It's still a linear search. You're still going to go through all the rows one by one. There's no optimization and indexes. It's going to help you rebuild a new index. It's going to build it from scratch. So same work involved. The result would look something on the lines of this. So you can have tags, keywords as part of your hierarchy, and the hierarchy will expose whichever way you want to access the information. So basically, that's a simple script will allow you to build. This is just an example, but it will allow you to build like case-by-case lookups. So the system is auditable. For another reason, you cannot use a database, by the way, is that if somebody tampers with a file system, file systems are auditable. Your database is not. Try auditing Postgres or Oracle, even worse. There's no way you can ever audit Oracle. If somebody tampered with your JVM and put something in there, how are you going to prove it? There's no way you'll ever be able to detect that type of hack. File systems are auditable because you can MD5 the basic binaries that came from the distribution of the operating system. The files are auditable, everything is auditable in there. You can create files which are immutable, so no other user can change them except the user that creates them and all this. It's a forensically strong system, although very simple. Anyway, logical deletions can be tracked in JSON, and every change is logged, preserving the chain of evidence because of the logs of the operating system. It's simple, for obvious reasons, and it's scalable. There's not much limits on file systems today. A file system can be exabytes. Try putting that in the database. Just the index will blow your database apart. Your file system can handle it. Searching through a massive file system like that will need a MapReduce approach. You know, you distribute it across a few systems and whatnot. But it's doable. A couple of scripts. Second case study. So it happened to us quite regularly throughout my, my career to have processes that fail for some reason after running for a day or two. And you just have either a core dump or something in your log saying you ran out of memory or the system bloated and died and you can't even SSH to the machine anymore. You have to restart it. Hopefully, if it's on the cloud, you can restart it without losing your ephemeral data. Good luck with that. Because sometimes you'll have to stop it and start it, which in this case will not be very, very successful. And sometimes you need a simple solution to see what's happening on the system, what CPU load you have, what memory leak over time, and have a graph showing what's happening. Now, usually we would use a tool like Grafana, which everybody heard about and was mentioned by our illustrious previous speaker. And yes, Grafana can help, but there are some problems. You can't always deploy it wherever you want on the fly and have it still be connected directly to the operating system, showing you each and every process on the fly as it's generated and destroyed. You won't be able to do that very easily with any sort of monitoring system. So this is a slightly contrived example, but something that came in useful. As you can see there's an HTML page, it's a very long page in this case, where you can see every command, every process that's running on the system, CPU, the memory over time as it grows. So when something is starting to pile up memory, you can see over the time how long it takes and why it's happening and which process is causing that. All the parameters with every process that is being called, so the full parameter set. Not what you get in HTOPs, showing you just the first part. You can run that command on your OS and it will run exactly the same. So no matter what's running, you will get the full thing. It has to have, in this case, a very low impact deployment, no dependencies, except what's already on the system in this case, which in our case was Node.js. Simple to deploy, tiny footprint. So, choices. I already spoke about most of this, but this is going to boil down to something that I started in our previous statement. So this is the code required to do that. The whole page. That's it, just that. There's nothing else. The functions, of course, are shortened. I collapse them, but it's 476 lines. At the end of that, you end up with an HTML file that you can copy and review. Try and keep it for reference, where you have all the PS files and everything that were run over time. It takes 500 lines of code to do that. I don't know why we need to install InfluxDB, Prometheus, probably some Elasticsearch, Kibana, Grafana, 2 servers, instead of 500 lines of code in Node.js. it's an easy win, I think, especially when you just want to solve a quick problem. It's a tool you can build very easily. The basic command is this. I think most of you know this. Anybody who touched Linux knows what PSAUX is. It's just parsing that and creating an HTML file out of it. By the way, the HTML code is all inside there, in those 500 lines. That's the full HTML code required. Sorry. How does this go? Sorry for that. Thank you. So the full HTML will produce something like this. And it's a very long page, so it's not going to be dynamic, it's not going to be smooth, refreshing. It refreshes, by the way, also. It's an HTML file. You can share it through like PM2 serve, boom, you have it on the network. You can pull it and use it anywhere and integrate it, and it's free. And costs nothing, and there's no servers, there's no installations, zero dependencies. Again, I just like to emphasize that point, because dependencies are the biggest nightmare I ever had in coding. So, this is the third case study I want to get you through, and I hope, how am I for time? I think it's okay. Yeah, this is basically a case study showing you how, although there are amazing tools outside there, you can't always use them. There are certain companies that will not allow, for example, Java. Military, some forensics. You cannot use Kafka in trading companies most of the time because it's not auditable. And one of the companies that had this restriction, which I started working for like 10 years ago, was you needed something. Kafka was brand new back then, it's 2016. And I think Kafka was just out version 1 and sucked balls at the time. But it was solving a problem that was quite new, which was this broker, as Precious explained before. It's basically you have providers which provide data with topics, and then the consumers on the other end. It's basically a glorified queue with a persistent storage to disk. The data stored on disk, by the way. When companies decide that they're not when their CTO decides, I do not want to have Java in this company, and the only product that does the brokers that you can find is Java, you start looking for a consultant. Enter me. Again, these guys have been running it for 10 years, and they needed a guarantee that it's going to be supportable and runnable for 15 years. Kafka's out the window anyway. I'd like you, anybody, to mention one system that will be around in 15 years. And started 10 years ago. Eliminate, they did not want any transient software like no JVM, no Zookeeper, something that is magic doing stuff in the background. They didn't even want virtualization on their system, so everything on bare metal. Like that, they had physical backups, they can check the blocks on the disk and copy them. By the way, it's much faster too. So this is the problem statement as it comes, you know, with a lot of words. But basically, it's what I was saying. And to cut a long story short, the idea started as basically a queue where you're putting data from multiple sources, and this would be scan codes at the entrance, customs, containers coming in. This is a shipping company. And they had trucks going around carrying containers, and they had to say where they are, what time they are there, logistics. Everything had to go through the system. There are 2 servers to do all this, by the way, and that's with redundancy. The system spoke through a system called packet radio, which today you would call Wi-Fi and other stuff, but back then they used inside ports. They have their own networking system for security. And so basically this thing had to be a binary that is deployable, upgradable, supportable over the years. So this is a map of what Kafka is to the OS-tuned C-based system. That's how I was selling it. And the idea is basically you have the broker, and I replace that with a C broker. And then there's the disk I/O and the log segments that Java creates, and there's something called huge pages and on the operating system, which you don't even need to do anything. You just configure it in your OS. Voila, you have super cache with 1 gigabyte pieces of chunks of memory, which is basically mapped to your memory using something called the TLB, which is translation look-aside buffer. It's something that I had to restudy because I forgot completely about these things when I came back to revisit this project. And yes, the idea is that at the time we could not use Kafka, even if we wanted, and I didn't want to. And I thought that reading a message from one side, saving it to disk, something called a huge TLBFS file system, which is a very, very fast way of having a file system in your memory rather than on disk. By the way, you can put file systems on your RAM, so you can treat a massive piece of data as if it was a file, without having to use massive pointers and globs and all those types of weird construction. You can just use file access. And then you can actually have something called mmap, which then allows you to copy that into a persistent disk. And these are all parts of your operating system, by the way. So study your operating systems back. They're very, very powerful machines. So yeah, huge pages, which is a technology which is common to most, because you won't be able to use it on a Mac directly, okay? Because a Mac hides it away, but the processor does it. It's just magic. But in Linux, you can actually say, I want a 2 megabytes or a 1 gigabyte huge TLB, and that means with one look aside, that means one pointer jump, your CPU already knows where 1 gigabyte of memory is. That will speed up your transactions to an order of magnitude that will make Java VM look really silly. There's something called ePOL2, which was enabled by somebody who serviced the software later, and we worked together on that, and he taught me how you can actually handle millions of connections on one 8-core server at once. Your operating system can listen to 1 million port connections at once. It takes a bit of tuning, a couple of variables. ChatGPT helps a lot in that as well, by the way, because those are complex to find, not because they're complex to do. They're really complex to find the documentation, but it has them somehow. Yeah, so basically huge pages are massive containers with one pointer rather than the CPU having to go to the memory controller, which on other systems is called an MMU, and on x86 is called a TLB and whatnot. But basically the idea is to reduce how much, when there's pressure to access more memory, how much to and fro the CPU has to do. Your OS does it. You don't have any applications required. You just need to know your OS. If you don't set these things, by the way, your pages are 4K, if I'm not mistaken. So any big block larger than 4K needs a page swap. Page swap means you're getting a pointer to a pointer each time. So 8 steps in assembly rather than 1. That's what TLB does. That means your code is 8 times faster to access the memory. It won't be 8 times faster in total. There's other things. Next. The event loop, basically ePOL is something like the event loop as we did it in Node.js. Anybody knows Node here? Does anybody work in Node? 1, 2, 3, 4. Okay, so you know some Node. The head of development, and she says she doesn't know Node. You're so humble. Okay, so in Node there's an event loop. In JavaScript there's an event loop. You can do that in your OS. It's always a poll under the hood. There's no such thing as a proper event on modern computers yet. That have to be wired when your CPU and RAM are one chip, then we can talk about that type of thing. But not yet. But ePOL is basically will only return events from anything that is connected in real time. When there's data, when your OS knows about it, you know about it. It's basically a callback. Now, this is, okay, I know the benchmarking is very ugly and the graphs are a bit wonky because scaling wasn't very good, but, you know, that was text mode for you. This is what Kafka gave you, which is 7 years ago. Not bad. 47,000 TPS at 8.2 milliseconds latency. Same benchmark. And this is what you get with C, 192,000 TPS and the latency of 1.3 milliseconds. 10 years ago. Sorry, I exceeded the 5.2. 5.22, it was, sorry. But yeah, 1.3 milliseconds turnaround. We had our first 10 gigabit NICs. That helps a lot with the latency and with the throughput of all this, but Kafka had the same hardware. Well, unfortunately, Kafka runs on Java, and Java has no idea what hardware you have. Your OS does. This is the difference. Just to keep it simple, I'm just going to say, spot the difference before and after. So these are the stacks required to run Kafka, and this is the stack required to run a C application with, by the way, this broker C does node peer-to-peer, so it could be scaled horizontally. It had gossip in it, which is a way for sharing the messages to its neighbors randomly, and those neighbors share it on. It had lock-free hash. It was multi-threaded, not done by me. I'm not that smart. But the first introduction to the atomic was me. And it maps onto ZFS, so it takes advantage of your NVMe drives, which have something called ZIL, which is the ZFS intent log. So basically, as soon as you tell your OS, I intend to write this set of bytes into this file, there's a system where it's done on a very fast NVMe drive, and then it will cascade. If your server goes off, failure happens, yes. If your server goes off halfway there, ZFS on startup will recover those ZILs and commit them to disk. So, you have all the features of Kafka without Kafka. And faster. Yeah. This is the code required for all that. 1,000 lines in C. Yeah, C, I know. It is a beast. Especially when you go into double pointers and all that. But this is not very complex. All you have to do is tune your OS and have your code in tune with your OS. Because your computers are part of your production. I don't know why we ended up in a world where people are writing software without understanding anything about what their computers can already do. When you can leverage the hardware, your software is going to be much faster. So these are the key takeaways, and I'm going to let your headache go away soon. So let the OS be your platform. Forget the languages. Those are tools. Those are ways of describing what you want to do. And if you can avoid the virtual machine, avoid it. Let the OS be your platform. I believe a lot in that. Complexity breeds bugs exponentially. I don't even think that is any qualifying. Choose boring technology. Boring is good. Yeah, if it looks like a lot of numbers and is boring and doesn't have a lot of syntax candy, it's probably better. Your architecture should be simpler than the problem. I don't know if anybody has a problem with that, but if you're trying to solve a problem and you create a harder problem to maintain than the problem you're trying to solve, you are suicidal. Yeah, infrastructure is a liability, not an asset. Back to the cubes and the pods and all these like automagic, all these tools where you can say, I want 200 front ends, and then I want 30 because I scale it down. We used to have something called auto-scaling on AWS before Kubernetes, and then Kubernetes came along and it looks like it's the only tool in town, but in reality you don't need that almost any time. If 3 servers can handle 1 million users, if you have 1 million users, you can afford another server. If you don't, your business guys need to be fired. So the systems knowledge is a fourth if you know your systems, your code will be multiplied in performance. It's not additive, it's multiplication. You're married to all your dependencies. The day you say, require this, remember, is this going to work in 5 years? Who created this code? And there used to be something called the Ruby nightmare. I don't know if anybody heard about it. But like all of a sudden your gems disappeared. You try to install a tool that was running 2 years ago. We've seen that somewhere. And all of a sudden we cannot find the basic dependencies that used to be in the repository because nobody maintained the repositories. And so every time you're married to a dependency, if you can, bring it on board. Get it into your company. Don't leave it on the cloud. Clear interfaces outlive clever implementations. That's the same point as before. Strive to reduce your code base. Your biggest aim is not to write code, it's to eliminate it. I swear. If you can get rid of 20 lines of code, it's probably 400 possible bugs that you got rid of, because it's usually a second order exponential. When you test your code, build for a horizontal, yeah, that's important too. When you build code, build it so it can, like I did with the broker, it can scale horizontally, but first, make sure vertically it's optimized. That means within your system, you're not wasting 70% of your CPU time idle waiting because you do not know what type of NIC card you have, so you're waiting using legacy calls. Tune it. You have the best computers in history. Use them. And this is another thing that I go by from my experience. Crash the system when you're testing it. Don't wait to see, oh, it works on my laptop. Yeah, okay, let's put it live. No. Crash it. Put it on a server and crash it. Get it to the system limits. Then you'll see where your weak points are. If it didn't crash, you're not testing it hard enough. If you're testing your code and you didn't crash it, you're not testing it hard enough. As simple as that. That's something I believe. Unless I saw my code crash, I don't know how it behaves under a crash. I'm not putting it live unless I saw it crash. Fair enough? So these are a couple of, I'm not going to make the mystery speaker because I failed miserably at guessing, so you can see over here. But the price of, there's one thing that you can never buy, reliability. That comes by keeping everything simple. Yeah, KISS, that's like back to the original discussion there. What happened here? Okay, we didn't lose it. Testing is inadequate, always. No matter how hard you test, you can prove the presence of a bug, you never prove that there isn't another bug you never detected. Simple basic lambda logic. You're never going to get beyond that. You can never show that, okay, this code has no bugs. I mean, it's a Godel problem after all. Like, you can never prove a system from within it. You can have systems which are self-proving. Hence, the functional languages were a beautiful idea. There's a new idea called immutable languages, which I think you might have read about. But end of the day, patience and skill take you miles away. They can really carry you into producing stuff that lasts till your children are grown up. In fact, mine is grown up and that code was out before. So that's it. Thanks for your time and attention. That's me.
Thank you very much. That was fascinating and illuminating.
Thank you.
I'm not a techie, not a software engineer, not anything like that. I'm a client. So
thank you for your service. Without you, we don't have a job, right?
Two observations. One is that in stressing simplicity, it means that the person who's giving you the requirement has to massively, deeply understand what the system is and also put the intellectual rigor in to be able to simplify it.
As a client, you mean?
Yes, as a client.
No, I don't totally agree. Usually, think of it like a lawyer, right? When the person goes to a lawyer, he says, I've got trouble. He usually doesn't have a good qualification of what he's talking about. He doesn't know the law. It's the lawyer's job to actually interpret the problem from experience, or in most cases it would be business development or somebody who supposedly knows what computers can do. But yes, you should be guiding, as an IT professional, I believe that part of our job as an IT team is actually guiding the client to say, okay, but do you really need this? Is this how much are you ready to spend? And how much are you ready to spend to optimize it? How long you want it to live? These questions should come from us, not from the client. Because the client's got his business to run. I don't think he gives a crap about C.
No, he doesn't give a crap about C, but he needs to understand his business.
Yeah, his business,
and
yes.
I've known many business people who don't understand their business. So I just,
wrong seminar.
Exactly, quite.
But yes, but with experience, a good IT consultant would usually know enough business to help guide the good. Listen, usually the customers, all they need to bring is the problem and the money.
Okay, fine, good. Second point, if I may, I'm sitting here and I'm hearing words I first heard 40 years ago.
Yeah,
I mean, has software development
You want the real truth?
not
The
advanced in the last 40 years?
The core fundamentals of our operating system is called POSIX. Came out in the 60s. Still here today.
Yeah.
Windows has to be POSIX compliant to be used in any government infrastructure. Unix is obviously was the POSIX standard, and then Linux is POSIX compliant. RTOS, is, if I'm not mistaken, is POSIX. Most operating systems are POSIX. Even Android is POSIX compliant. Like, yeah, those things are not going away. What happened is the capability of the hardware became so complex that the software had to put in a lot of magic to tell it, yeah, we can use this here, we can use this there. They're called drivers.
Yeah. Okay, understood. And finally, in this ecosystem going back 40 years, we suddenly got LLMs and everything. I mean, how are these things coexisting?
Very well, I would say. I would say that it's a breakthrough in... Listen, we're talking of a 2-year-old toddler when we were arguing that's capable to get a PhD. Give it some time. The reality is that all the systems that you see LLMs are not running on Windows, ever. They're running on Unix or Linux or something akin. So yeah, the old technologies are still running today and they're still going very strong. Anybody who tells you otherwise is bamboozling you. Anything new is based on the old stuff, and if you know the old techniques and you move at a lower level, you are going to be in better position to leverage anything that's above you. Anything else?
Okay, I see one more hand.
Thank you for the talk. I come from Mesozoic era. I'm still balding. I had a very interesting experience recently in one of the companies where I was managing the dependencies.
Oh,
so yes, no, I was managing them out.
Good. That is
so I've removed maybe a couple of million dependencies.
Million
lines of dependencies. Sorry.
Oh, okay. Three libraries in Java.
It was like 20 libraries in Go, and the most important thing was that whenever I removed the library completely, replacing it with the same code, the code shrunk of our system.
Of course, of course.
And I have a small confession. Could you get back to the CNCF thing?
What do you want to see, sorry?
The list of CNCF landscape.
Okay, let's see. The landscapes, right?
Yes.
Okay. Jesus, I didn't realize I made so many slides.
Yeah, I'm sorry for adding another icon on this list, first of all.
Well, in reality, the advantage here is that the percentage of damage you create is nothing compared to that list. Yeah. Like 0.01% of a problem is nothing compared to the 100% that's there. So,
another thing is that I have tried a bunch of the things from the list, replaced them with, I don't know, 200 lines of bash. Or
sorry, how many centuries old are you?
I'm a little bit younger than you, I guess, but not much.
If you went through all these...
not through all of these, but maybe a dozen of them. Replaced them with a bash or Perl or Go in some cases.
Yeah, where possible.
And that's probably why my company died, because everybody was replacing our solution with Go or bash.
Fair enough. Did it work well?
No, not really.
Well, they didn't do it well then. Skill is still a thing, you know. Anybody else?
Okay, any more questions? Do you have any more hands? I do not see, sorry.
Okay.
Okay, no hands, yes? Great. Thank you very much. It was very interesting and amazing. I can't say that I understood everything, but I was trying. Thank you. Okay, thank you very much. Thank you everybody for participating, and as usual, thank you IT team for supporting us. Thank you development recruiters who help us. Thank you Nikolai Markov who help us to prepare presentations as well. And I hope see you next time. We still have some food and drinks. That's why don't be shy. Please eat it. It's very important. And we have, I believe, around 30 minutes for small networking. And I promise I will not interrupt you during these 30 minutes. Well, enjoy. See you next time.